Because of the job they're called on to perform, quite a lot of engineering components can only be made in very special ways, using very special materials. Some of these components we recognize immediately, others we rarely see, but all of them have a vital and specific engineering role to play. The fewer parts you have, the better. This means that single units can often have quite a complex shape. In one piece, you may have united many functions. So how does a manufacturer set about making a wide range of metal shapes to the precise sizes, strengths and surface finishes demanded by the customer? It's a problem that's usually solved by discussion between engineering designers, production engineers and metallurgists. It's during such talks that production plans are laid down. So it's important to get a fine balance between what the customer wants and what is possible using a particular production technique. The production process finally chosen is often influenced by the material itself and the shape of the final product. One option open is to cut the material from a metal blank. The main drawback is that this is an extremely wasteful way of doing things and usually very expensive. You could always, of course, forge the part. Take a metal blank, usually made from steel, and form it into a new shape by applying great force to it. It's a speedy operation, but the cost of the pressing machines and the running expenses are high, and the range of possible designs and the metals from which they can be made is relatively limited. So you can see that there's a definite need for a forming process which makes a wide range of shapes from a wide range of materials. One technique is to melt metal and pour it into a preformed cavity. This cavity is called a mold, and it has the same shape as the finished article. When the molten metal has cooled and solidified, it's assumed the dimensions of the mold. All you have to do then is knock it out of the mold. It's a process with a long history, and it's called casting. Casting metal dates from beyond biblical times. The technique fascinated the Victorians, who cast everything from railway stations to bandstands, from cannons to elaborate cast-iron coffins. The great advantage, then as now, is that it's one of the quickest routes between an engineering drawing and the finished article. One of the oldest and best tried methods of casting is the one which uses sand to make the mold. To create a solid object by sand casting looks fairly complicated. First of all, you have to make a pattern, and traditionally this is built out of wood. Patterns that are going to be used over and over again may well be made out of cast iron, aluminium alloys, or fiberglass. But the traditional wooden patterns are made from yellow pine or mahogany. Wood doesn't cost very much, and it can be easily machined and cut. If minor design changes are made, then the pattern can be altered fairly quickly. At this foundry, they make a wide range of engineering components. All of them start life in the pattern shop. It's here that the designer's drawings and dreams are turned into hard and durable reality. There are patterns for everything you can think of. Parts for power stations, parts for North Sea oil rigs. Each piece is unique, and each has its own individual wooden pattern. A British standard colour coding system for patterns shows whether part of the casting is to be machined or not. Red indicates that the surface is to be left just as it is when it comes out of the cast. Black is used to show the position of the sand cores.